Hello, friends. Are humans the only intelligent beings in the universe? Or could there be others out there? If extraterrestrial life exists, it's natural to wonder whether they ponder the same question. Are they alone in the cosmos? With this curiosity in mind, NASA has led multiple projects aimed at reaching out to potential alien civilizations. One of the most ambitious was the Voyager 1 mission, launched in 1977. The primary objective of this spacecraft was to explore our solar system, study its outer planets, push beyond the sun's influence, and enter interstellar space. A mission unlike any before it. Our Milky Way galaxy contains millions of solar systems, separated by vast stretches of what we call interstellar space. To date, NASA has launched only 5 spacecraft designed to explore beyond our solar system: Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. But of these, only 2, Voyager 1 and Voyager 2, have successfully reached interstellar space, an achievement that took decades due to the immense distances involved. These 2 spacecraft provided some of the most breathtaking images of Jupiter, Saturn, Uranus, and Neptune. In fact, Voyager 2 remains the only probe to have ever visited Uranus and Neptune up close. Meanwhile, Voyager 1 holds the record as the farthest man-made object from Earth, having traveled more than 24.7 billion kilometers as of October 2024. But perhaps the most intriguing aspect of the Voyager missions is the message they carry for extraterrestrial life. Each Voyager probe carries a special payload, the Golden Record, a collection of sounds and images representing life on Earth. The hope was that if an intelligent alien species ever found these spacecraft, they would gain insight into humanity. The idea for the Voyager missions began in 1965 when a NASA engineer noticed that in the late 1970s, the outer planets, Jupiter, Saturn, Uranus, and Neptune, would align in a rare geometric configuration that occurs only once every 175 years. This alignment allowed for a unique mission using a technique called gravity assist, where a spacecraft can use a planet's gravitational pull to gain speed and adjust its trajectory with minimal fuel consumption. This led to the development of the Voyager program, with the launches strategically planned for 1977. Voyager 1 was designed to fly by Jupiter and Saturn, with a special focus on Saturn's moon, Titan. Meanwhile, Voyager 2 was set to visit all 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. Both spacecraft were equipped with similar instruments, including a 2-camera imaging system, spectrometers, magnetometers, and a high-gain antenna to communicate with Earth. They were powered not by solar panels, since sunlight becomes too weak beyond Mars, but by radioisotope thermoelectric generators that convert heat from decaying plutonium into electricity. Voyager 2 was actually launched first on August 20th, 1977, followed by Voyager 1 on September 5th, 1977. Although it launched later, Voyager 1 took a faster trajectory, reaching Jupiter in March 1979 and capturing stunning images. It was during this flyby that we discovered Jupiter's faint ring system and the first active volcanoes outside Earth on the moon Io. Until then, scientists believed Jupiter had only 13 moons, but Voyager 1 helped identify new ones. Voyager 2 arrived at Jupiter a few months later and got even closer, leading to the discovery of yet another moon. These missions increased our understanding of the Jovian system, a term derived from the Roman god Jove, also known as Jupiter. Similar to Jupiter, Saturn, Uranus, and Neptune are massive gas giants with rings and multiple moons, which is why they are collectively called Jovian planets. In November 1980, Voyager 1 reached Saturn, uncovering 3 new moons: Atlas, Prometheus, and Pandora. Pandora, interestingly, shares its name with the fictional alien planet in the movie Avatar. At the time, Saturn was thought to have only 15 moons, but today we know it has at least 146. One of the most fascinating discoveries was Saturn's moon Titan. This celestial body is the only place in our solar system, apart from Earth, where liquid bodies of water have been observed on the surface. Titan's potential for hosting life has made it a subject of many science fiction stories and scientific studies. After its Saturn encounter, Voyager 1's trajectory took it out of the solar system's ecliptic plane, the imaginary flat surface on which most planets orbit the Sun. Meanwhile, Voyager 2 continued its journey, becoming the first and only spacecraft to fly by Uranus in 1986 and Neptune in 1989, sending back remarkable images of these distant planets. By 1990, NASA officially declared that Voyager 1's mission had transitioned into an interstellar expedition. On February 14, 1990, Valentine's Day, Voyager 1 took one of the most famous images in history, the pale blue duck. Captured from 6 billion kilometers away, this image showed Earth as a tiny speck in the vastness of space, reminding us of our fragile existence in the cosmos. After taking this family portrait of the solar system, Voyager 1's cameras were turned off to conserve power. For years, it continued its silent voyage toward interstellar space. In 1998, it officially became the most distant human-made object from Earth. Then, in 2004, Voyager 1 crossed the termination shock, the boundary where the sun's solar wind begins to slow down drastically. Finally, on August 25, 2012, Voyager 1 left the heliosphere, the bubble of charged particles surrounding our solar system, and entered interstellar space. This milestone took NASA months to verify, and in September 2013, they confirmed that for the first time in history, a human-made object had left the solar system. How did we determine this? Voyager 1's plasma wave instruments detected a sudden increase in electron density, indicating it had entered a region dominated by interstellar radiation rather than solar wind. Scientists had long speculated about the existence of a bow wave region at the edge of the heliosphere, but Voyager 1's data led to a major revision of these theories. Today, we understand this boundary as more of a diffusion zone rather than a clear-cut edge. Voyager 1 continues its journey into the unknown, sending valuable data back to Earth through its high-gain antenna, received by NASA's Deep Space Network stations. The Deep Space Network stations are incredible feats of engineering. Located in 3 strategic locations, California, Madrid, and Canberra, Australia, they provide near-complete global coverage for space communication. In this animation, you can see how these stations work together to track distant spacecraft. If you've been following my vlog channel, you might remember our tour of the Deep Space Network station in Australia. If you missed it, the link is in the description. Now, let's talk about Voyager 1. When researchers analyzed the data, they pinpointed the exact moment it crossed into interstellar space, August 25, 2012. Coincidentally, this was the same day Neil Armstrong, the first human to walk on the moon, passed away. But what about Voyager 2? It followed 6 years later, entering interstellar space on November 5, 2018. To this day, these 2 Voyagers remain the only spacecraft to have ever ventured that far, and both are carrying messages intended for extraterrestrial life. Interestingly, the Voyager missions weren't the first to attempt interstellar communication. Before them, Pioneer 10 and Pioneer 11 carried messages as well. However, the Voyager records were far more advanced and detailed. The Pioneer spacecraft featured a small, gold-anodized aluminum plaque known as the Pioneer plaque. This plate, just 15 centimeters by 23 centimeters, includes 5 engraved diagrams, one of which is a map of our solar system. It marks the position of the Sun relative to 14 pulsars, acting as a cosmic address for anyone who might find it. At the bottom, an arrow points to Earth, indicating where the spacecraft originated. It even includes simple depictions of a man and a woman to give aliens an idea of what we look like. NASA described this plaque as a mark of man. While the Pioneer plaque was a bold step, the Voyager Golden Record took things to the next level. Instead of a simple engraving, it contained a rich collection of information, images, sounds, and even greetings in 55 languages. These 12-inch gold-plated copper discs, resembling phonograph records, hold 4 main sections: Scenes from Earth, 115 images and diagrams showcasing our planet, life, and scientific concepts. Greetings from Earth. Spoken greetings in multiple languages, including messages from then U.S. President Jimmy Carter and UN Secretary General Kurt Waldheim. Music from Earth. A diverse selection of 28 musical pieces, spanning different cultures and time periods. Sounds of Earth. 21 recordings of natural sounds, human activities, and mechanical noises. But how would an alien civilization actually play these records? NASA included instructions, but not in any human language. Instead, they used diagrams to explain how to operate the phonograph. The question is, would an extraterrestrial being be able to interpret them? Take a look at this diagram. Does it make sense to you? If decoding the sound is tricky, extracting the images is even more complicated. In 1977, digital image storage technology was extremely limited. NASA's workaround? They projected images onto a screen, recorded them with a television camera, and converted the video signals into audio waveforms. The result? The images on the golden record are actually stored as sound. To view them, an alien civilization would need to reverse engineer the process. Once decoded, the first image they'd see would be a simple calibration circle, proof that they got it right. Following that, they'd find images explaining mathematical and scientific concepts, a visual map of our solar system, and stunning photographs of Earth. Among them are shots of famous landmarks like the Great Wall of China and the Taj Mahal. Interestingly, there are no images of war or conflict, only an idealized version of humanity. The biggest question remains, will any of these records ever be found? And if so, will the beings that find them have the intelligence to decode them? Let me know what you think in the comments. As of now, Voyager 1 is traveling at an astonishing speed of 61,198 kilometers per hour, more than 25 billion kilometers from Earth. It's deep in interstellar space, but unfortunately, its power supply is running low. Scientists predict that by 2025, it will no longer have enough energy to communicate with us. However, its golden record will continue drifting through space, perhaps for eternity. If you enjoyed this video, check out my previous one on Area 51. What's the real secret behind it? Click here to watch. Thanks for watching.